Hello, good day, and welcome to another few minutes of math. Look down at the counter. Hopefully, the timer doesn't show much. Hopefully, it's not even 10 minutes. Hopefully, it doesn't show too long. We'll just spend a couple minutes together today talking about an aspect of geometry, called a scale factor, or if you're scaling something, not like scaling a wall, going up over a wall, but making something that was big, small, or was small, big, changing the signs. For example, like this right here. Let's do a smaller scale of me. There we go. It's still me. I've still got the same proportions, but it's just bigger and smaller. So it's just a matter of scaling something that's the exact same object, just do a smaller or larger example of the object. So we'll get into some examples of it. Hollywood has some examples of it. Back in decades ago, they had these movies, Honey, I Shrunk the Kids, or Honey, I Blew Up the Kids. Recently, there's been movies like Ant-Man and the Wasp, where the entities either, it's the same entity, just either larger in size or smaller in size. We're going to do it with geometry, with geometric figures mainly. Let me dive right in. Have you ever built a scale model of something? When you build that scale model, they study the dimensions, and this is the exact same dimensions of a plane. When you make a scale model, they just made it with smaller dimensions. Or when they do a house plan, on the actual house plan, it'll say, hey, this is 19 feet by 22 feet, or this is 11 feet by 20 feet. And then they'll have a scale drawing of it that they can work with in actually building the actual home. It says it's 60 feet this way and 47 feet this way. It just helps them see how the scale drawing helps them get an understanding of the actual item. Architects in say building homes, they'll sometimes actually build an actual model of the home before building the home to see if it looks as what they expect it to look. So those are just a few real life examples of where using a scale factor occurs in real life. There we go. I'll kind of discuss some of these ideas with a scale factor and how we use it in math, just to kind of practice and to learn how to use scale factors. Let's say that I've got a geometric figure, and it's got lengths of maybe 3 and 6 and 10, and I want to increase it by a factor of 6. If I want to increase it by a factor of 6, and I just multiply, it's like the factors of a number. You're multiplying when you're doing the factor. So it's a factor of 6. I'm multiplying it by 6. So each one of these, I'm not drawing it as big as it would be, but instead of 3, it's 3 times 6. This side is now 18. And 10 increased by a factor of 6. So 6 of them makes it 60. And 6 increased by a factor of 6, or multiplied by 6, is 36. That's what it means to use a scale factor. What if I wanted to increase it by a factor of 1/2? Well, you then multiply it by 1/2. So what was 6, when you multiply it by 1/2, becomes 3. So you can see how it gets smaller if this factor is less than 1. That 1 is a middle number, you can say, in terms of what it does to a factor. So it's going to be getting smaller. 3 times 1/2, this becomes 1.5. And 10 by a factor of 1/2, 10 times 1/2 becomes 5. Well, to get really complicated, what if I want to increase it by a factor of, let's say, 5/4? Well, again, it's just multiplication. You're just multiplying each of these by 5/4. So 3 times 5/4 becomes 15/4. 6 times 5/4 becomes 30/4. You can use a calculator and hit pause if you'd like. 10 times 5/4 becomes 50/4. So that's what it means when we're changing a scale factor. We can change it so the item is larger or smaller, but that's what it means to use a scale factor to change the size of something. Well, what if I told you that one item was right here, I've got a square and all of its sides are 5, and then I give you another square and its sides are 15. What's the scale factor? Can we find the scale factor on it? Yes, we can. The scale factor is simply whatever the original number, that's the denominator, the original amount, and then you put the new item on top, the new measurement. So let's see, the original amount is 5, and it goes to 15. You can already see this, but that's why I did it this way. So you can say, well, all we did was times by 3. Yes, 15 divided by 5 is 3 to 1. Or the factor, you could say a 3 to 1 factor, or you could say 3. If I have, let's say I've got a hexagon, and all the sides are 6, and I've got another hexagon, and all the sides are 2, and I tell you that it's a scale factor, what is it? Well, the original amount goes on the denominator, and the next one goes on the numerator. So the scale factor 2/6, that reduces to 1/3. 1/3 is the scale factor on that one. To find the scale factor, you simply take the original number, put it on the bottom of a denominator in the bottom of a fraction in the denominator, and put the new one, the new number of that same side in the numerator. And you just make sure you compare the same sides. These are all sides 6. These are all sides 2. You're comparing the same side. So this 6 would be compared with that 2. This 6 would be compared with that 2. In case you had a shape like this, where you had different sides, so this is 1 and 2 and 3 and 4. If these ones were 8 and 12 and 16, you'd be comparing the 2 with the 8. So the 2 goes up to an 8, that's a factor of 4. And then you can check all of these. Are all of these a factor of 4? Yes, they are. And if they are, then you know it's a scale factor. The one shape is a scale factor of the other shape. Well, what if you need to find a measurement? And I tell you that this one is 1 and 4 and 7. And this one, I don't tell you what this one is. Let's say I call it X. And let's say this one is 24, and we don't even list that one. Could you tell me what this one, if I say that they are a scale factor? We use the word similar. If they are similar, could you tell me what this is? Yes, you could, and you simply build a proportion. If you know that that's the same, if you know this is a factor, then this is a factor, and this one is a factor, then we can just build a portion. We know that 4 is to 24. Whoa. 4 is to 24, and we just compare them in the same order. 4 is to 24 as 1 is to X. And then we can solve that proportion that you've been doing all year long. 4 times X, that's 4X. 24 times 1 is 24. Divide both sides by 4 so that X equals 6. So that answer, the number there, the measurement there is 6. And I can do that with any of these sides. Oh, so if that's 6, then I know that 1 is to 6, 1 is to 6, and if I wanted to even find this one, 1 is to 6, so then I can do 7 is to this one right here. I'll call it Y. 7 is to Y. And you can cross multiply 1 times Y, 6 times 7 is 42. Oh, so that means Y is 42. And the way you find the missing measurement in a similar, or if there's a scale factor going on, you simply build the proportion. I built it this way. You could have built it like this. Watch this. I have 4 is to 24. I could have done this. I could have said 1 is to 4 as X is to 24. You can compare them in different orders as long as you compare the same direction. This side with that side has to equal this side to that side if they're proportional. Because when you cross multiply, you're going to get the same equation anyway. That's how you find a measure. Well, and lastly, are they similar? Or let's say I've got one rectangle and another rectangle, and the question is, are they similar? If this one is 2 and this one is 8, 8 and 2, this one is 1 and this one is 6, 6 and 1. Are these similar? Well, you can tell if they're similar if they have the same scale factor. To go from here to here, I cut it in half. I multiplied by 1/2. So when I multiply 8 by 1/2, do I get, oh, I don't. I don't. So those are not similar shapes. If I've got myself an octagon, a stop sign octagon, and I say that all the sides are the same, and this one is, these are all 4, and these are all 1. Are those shapes similar? Let's see, I divided by 4, or I multiplied by 1/4, and then you just make sure you do that on all of them. So yes, if I could draw a thumbs up, yes, those are similar shapes. If I have a triangle and this one is that with length 3, and that's length 4, and that's length 5. Let's say this one right here is 9 and 12 and 15. Are those shapes similar? Well, let's see. 3, I multiplied by 3 to get 9. 5 times 3 and 4 times 3. Yes, they're all multiplied by the same factor, so they are similar shapes. They do have the same scale factor. So that's it. That's the message of today's scale factoring. I was really small there for most of it, large at the beginning, and then I can up and down. It's a different scale factor. I'm actually looking at my sliding scale. There's 90% of the screen, and there's 5% of the screen, but it's a scale factor. And that's going to be the image in your mind and what this means on the scale factor. Thanks for watching. Hope it was a little bit beneficial, even though it was a little more than 10 minutes. Talk to you later.